Welcome everybody, it's Ramchandra again from CIVIL-MECH-MATHS concepts. In the last lecture, in structural analysis 13, I have explained about the beam vibrations for a cantilever beam. In this lecture, I will be explaining about the beam vibrations in simply supported beam. A simply supported beam has two supports at the ends and it is loaded, external load, it is applied with the external load of P at the center. Then if M is the self weight and E is the Young's modulus, I is the second moment of area and L is the length of the beam, P is the external load at the center of the beam and this is the length of the beam. Then for a lowest natural frequency, the equation is given by omega square is equal to, it is in radians per second whole square, is equal to EI pi by L to the power of 4 into L by 2 whole divided by P plus M by 2. And to convert it into hertz, as we have told in the last class, omega is equal to 2 pi f, so that f is equal to omega by 2 pi. F is in hertz, omega is in radians per second. 2 pi is the constant. Now, for a simply supported beam, as in the cantilever beam, how to get this equation? I will give a brief. As far as the integrations are concerned, you please do them as homework. Now, what is our basic notation for the omega square? Omega square is equal to integral EI d square y by dx square whole square dx divided by integral y square dm. Here, in the case of an simply supported beam, the geometry will be like this. These are support reactions, and this is the central load P, and this is the length of the beam L, and from one end, if you take a distance y, the shape of the curve will be deflection, will be like this. The bending moment at B is equal to 0. The bending moment at A is equal to 0. At supports, the bending moment is 0. And the bending moment will be maximum at center. For this condition, bending moment is maximum, which implies deflection is maximum. That means deflection delta max you can call it as, or you can call it as y max, as in the previous example. This is y max, this is y max, and at any point x from one end, this value is y, that is the deflection. Maximum deflection is y max at a distance from one end of the support on the beam at a distance of x, the deflection is y. Then we have to find out the equation of this deflected curve. What is the equation of the deflected curve? Deflected curve is equal to, curve is given by y is equal to y max into sin pi into x by L. This equation you please remember. This is very important. In the cantilever, the equation is y is equal to y max into 1 minus cos pi by 2 x by L. Here it is y is equal to y max sin pi x by L. Now, let us check the boundary conditions. When x is equal to 0, this implies y is equal to y max into sin pi into 0 by L. That is equal to sin 0 is 0. Y max into 0. That is equal to 0. That means the boundary condition here is satisfied. And at x is equal to L, y is equal to y max into sin pi into L by L. That is sin pi. Sin pi is 0. That means y max into 0 sin pi. Sin pi is 0, that is equal to 0. That means here also the boundary condition is satisfied. At both the ends, the boundary condition is satisfied. That means this equation we can say it is valid. And at x is equal to L by 2, let us say, it should be maximum. At x is equal to L by 2, y is equal to y max into sin pi into L by 2 by L, that is equal to y max into sin pi by 2. What is the value of sin pi by 2? That is 1. That is equal to y max. That means at x is equal to L by 2, y is equal to y max. That means it is satisfying all the boundary conditions. At the support ends, the deflection is 0. At the center, for the given loading condition that T is acting, external load is acting at the center of the beam, that is y is equal to y max. That is the maximum deflection we get at the center. Now, if y is equal to y max into sin pi x by L, that implies dy by dx. If you have studied your differentiation in your secondary school or higher secondary school, you will understand dy by dx is equal to y max into pi by L into dy by dx of sin x is cos pi x by L. That implies d square y by dx square is equal to minus y max into pi by L into pi by L is pi by L whole square into sin pi x by L. That is y max into sin pi x by L is nothing but y. That means this becomes y max into sin pi x by L is nothing but y. D square y by dx square is equal to In terms of x, we can say y max into pi by L whole square into sin pi x by L, or we can say minus y max into, in terms of y, whatever in the examination it is asked, we have to do. Y max we need not write, because y max into sin pi x by L, we are writing it as y, so that minus y square into sin, you need not write sin pi x also, that is also taken care of, pi by L whole square. That means d square y by dx square is directly proportional to minus y square, because for the given length of the beam, pi is constant, L is constant, and d square y by dx square, the second derivative of the curve of the deflection is directly proportional to minus y square. Not minus y square, sorry, minus y. Because y max into sin pi xl is y only. You please see. This is one of the observations we made from this equation. This type of questions only will be asked in the examination, because these will not be given in the textbooks. We understand in depth, then only we can understand it. Or else we can even say d square y by dx square whole square is directly proportional to y square. The square of the second derivative of the equation of deflection is directly proportional to y square. These are the two derivations from this particular equation. We will further go ahead. Now, what is our equation for omega square? The general equation. What is the general equation? General equation is omega square is equal to integral EI d square y by dx square whole square dx by whole divided by integral y square dm. This is our general equation. In this general equation, integral of dm we know, that is m, y we know, d square y by dx square we know, whole square we know, and Young's modulus is known, I, the Young's modulus is on the material property, E is equal to material property. I is equal to cross-sectional property. It is the property of the cross-section. Second moment of area, m to the power of 4. Second moment of area. And E is equal to in pascals. That is Newton per square meter, Young's modulus. And Y is the deflection at x. And m is the self weight of the body in newtons. P is the load in newtons. And when we solve this whole equation, d square y by dx square whole square is how much? D square y by dx square is equal to minus y max pi by L whole square sin pi x by L. You just see, d square y by dx square is equal to minus y max into pi by L whole square d square y by dx square is equal to y max into pi by L whole square into sin pi x by L. Because it is to be integrated with respect to dx, the numerator will keep in terms of x only, d square y by dx square. Then d square y by dx square whole square is equal to, it is minus, then it will be y max square into pi by L to the power of 4 into sin square pi x by L. This is to be substituted here. Ei is a constant. Then y is, what is y? Y is equal to y max into sin pi x by L. dm. Integral y square dm. M is self weight of the beam of length L. For a dx length, self weight will be m into dx by L. Please try to understand this. Then what will be the value of dm? dm is equal to m into dx by L. This is for m. There is another load, external load also. Hence, how to calculate? Integral y square dm, which is the denominator. How we will calculate? We will substitute these values. What is y? Integral y max sin pi x by L y max into sin pi x by L, this whole square. What is dm? dm is equal to m into dx by L. And this y square dm is not only for, this is for, this equation is for, m means don't take that it is only for self weight. It is for self weight, and another load is also acting on the beam. That beam loading, for that beam loading, y square dm will be load into y max square. Actually, y square dm, the meaning of y square dm is, there are two types of moment of inertia. One moment of inertia, we usually do it in mechanical and civil engineering, taking care of second area of second moment of area. It has the units as m to the power of 4. Second moment of area, another moment of inertia is That is from Newton's law. Inertia is caused by mass. That is mr square. That is equal to mass into distance square. That is equal to applied load into distance means deflection by which the beam is deflected. Maximum deflection whole square. That means this mi units are, this is equal to P into y max square, that is equal to Newton meter square. One moment of inertia is second moment of area, that is m to the power of 4 units. Another moment of inertia on the basis of the mass moment of inertia. This is called as moment of mass, we can rather say. Moment of mass. It is second moment of area. This is second, we can say second moment of mass. mr square. I am just calling it. I don't want to be bookish in all these things. I want to be practical and teach you practically what is what. Now, once we have got these values, integral y square dm is with you, and d square y by dx square whole square is also with you. Then we can go for the final answer for omega square is equal to integral, what is that, omega square ei d square y by ei into d square y by dx square whole square dx, correct, whole divided by integral y square dm. I have given you everything. Y square is there with you, y square dm is there with you, and integral ei d square y by dx square whole square is there dx. Then this becomes, do the integration as a homework, place the values whatever I have given you in the just briefed explanation to you. Treat it as a homework, integration as a homework. I have given all values to you, you put them and integrate. Now homework as integration, then we will get final answer as omega square is equal to ei pi by 4 pi by L to the power of 4 into L by 2 whole divided by P plus m by 2. Now, as in the previous class, let us discuss about the three cases. This is the first case where when P and M are present. P is external load, M is the self weight. If self weight is neglected, if self weight is neglected, m is equal to 0. That implies omega square is equal to ei by 2 into pi to the power of 4 by L cube P, which we can approximate to 48 EL by PL cube. 48 EI by PL cube. If self weight of a simply supported beam, if self weight of a simply supported beam is neglected, then omega square is equal to 48 EI by PL cube. This is SSB. What about cantilever? We have derived earlier in the previous class. 3 EI by PL cube. There can be a question, what is the ratio of omega of SSB to cantilever? Question is like this: ratio of omega, or we can say natural frequency, lowest natural frequency of SSB to cantilever. Omega square of SSB divided by omega square of cantilever is equal to 48 EI by PL cube whole divided by 3 EI by PL cube. If SSB is as previously loaded, SSB central load is equal to P, then this will be 16. That means omega SSB by omega cantilever is equal to 4. This is the answer. Please understand the concepts clearly, and ultimately for simply supported beam, omega is equal to square root of 48 EI by PL cube for a simply supported beam of length L at center load P. With this, I want to conclude today's lecture. You might have understood the comparison between a cantilever beam and a simply supported beam, their deflections, ratios of their frequencies, and the natural frequency of simply supported beam is more than the frequency of a cantilever beam for the same length, for the same load. In the simply supported beam, in case of simply supported beam, the load is at the center of the beam. In case of cantilever beam, the load is at the end of the beam, free end of the beam. The cross sections are same. When EI is same, length is same, load is same, the omegas are in the ratio of 4:1. And these type of questions, tricky questions, will be asked in the examination. Please be confident to answer them without any hesitation and confusion. And I am from Civil Mech Maths Concepts channel, and my name is Ramchandra. Please subscribe to my channel for regular updates. I will be regularly releasing this. Going ahead in the subject in the next class, because we have done for the cantilever beam and also simply supported beam, the vibrations, natural vibrations, we will go for exactly how to find out this frequency, natural frequency. And already we know omega is equal to 2 pi f. In hertz, if you want answer, this can be, once omega is found, we can find f in hertz. And this we will be doing it for the previous example, that example on which we are working on, that example we will be taking up, and we will be answering we will be solving that problem regarding vibrations in the next class. Best of luck to everybody. Thank you for listening to me. Thank you for viewing my video. Please subscribe to my channel, and please review. Almost more than 30 videos are released on civil engineering subject, and more than 20 videos are released on engineering mathematics. Total about more than 56 videos are released. Please view them, review them, and comment on them so that I will answer to your queries. Thank you for listening to me. Thanks a lot. Best of luck.